Okay, so picking up exactly where I left off in the last video, I haven't changed anything. So you can follow along here. What we're going to do is continue working on the simulation of the flame effect for the flamethrower. Okay, so let's go back into the ice tree and let's continue adding nodes here to change the way that this thing behaves. You notice that my ice tree is getting kind of big and these nodes are taking up a lot of room. So to keep things more organized, let's go ahead and collapse some of this stuff. For example, if we use these little 3 gray bars, we can go ahead and click on them to collapse this stuff and make it smaller, tuck it out of the way. We can also middle mouse button click on, say, the set particle age limit node, and it'll branch select all of the nodes that are connected to it below it in its hierarchy. Okay, and then you can hit Control R to reorganize them, and there we go. Just a better way of working. I'll do the same thing over here to all the nodes that are controlling the modified particle size. So I'll middle mouse button click on the first node here and all connected nodes, in this case this one node here will go ahead and be selected. Then I can hit Control R to tuck them away like so. I'll do the same thing for the spin particle, just tuck it away. That way we have more room to work in and things are a lot more organized. Alright, so let's start to add some forces. I'll go back to the preset manager. I'm going to go ahead and type in the word forces or force. And I want to bring in an add forces node. I also want to bring in a null controller force. And we also want to bring in, say, a gravity force. We'll need one of those. And I think we'll be good with that. So let's close that. Okay, so first thing we need to do is add this forces node to our ice tree. Let's add it between the spin particle and the delete particle at age limit node down here. So we'll right click on top of port 4 and click on insert port before, and now we can connect this add forces port right there. And now we'll see, let's bring in the null controller force here, and let's go ahead and plug that into force 1 of add forces. You'll notice that it's red, and that's okay. That's because we haven't brought in a null yet, and I'll show you that in a moment. And we'll plug in the gravity force into the second port here for the forces. Okay, if we open up the forces node, we don't really get any parameters here, so that's okay. And the null controller force is red because it wants an actual null object to be connected to it. If you remember, in this tutorial, during this series of videos that come with this training product, we did cover the null controller force. So you got to see how it works and its technicalities and things like that. Now you'll get to see it in action in a real production scenario. So let's collapse this. What we have to do is create ourselves a null to use as the controller. So I'll go back to the first frame of the animation just to get rid of those particles. And let's go ahead and go to primitive, select null. Let's move the null out here somewhere. It doesn't matter at the moment. I'm going to go ahead and hit enter to open up its PPG, and I want to change its name. Let's call it Flame Controller, just to keep things organized. Let's also change its primary display icon from null to rings, which will work a lot better. Close the PPG. Alright, we have to take this null and position it a little bit better. So what I'm going to do is I'm going to, in the Y, it's might be a little bit too high. Let me move it lower. What we're gonna use this null controller for is to push the particles up. Just give it a little bit of a nudge when the particles hit it, just to kind of make it curve at the end and make it snake up just a little bit. Just gives us a lot more control over our particles. And let's move it in the Z-axis. Let's move it far away from the flamethrower because those flames are going to reach pretty far. So let's move it about, I'm looking at my numerical field right there. So I want to get it to about 120. Somewhere between 115 and 120 will work out just fine. So that'll work out. I also want to scale it up. It needs to be bigger because if it's too small, it's not going to have much of an effect, if at all, on the particles. So let's make it real big. Let's scale it up to about here. You notice here in the numerical fields in the MCP, I'm close to about 10. So you don't have to be exact. As long as you're close to 10, it'll work out pretty good. So 9.7, 9.6, or 10 will work out just fine. It's not going to make much of a difference. Okay, so there we go. So we have this null controller out here. Now next thing we need to do is make sure that you have the null controller selected. Open up the ice tree and now hit F3 on the keyboard to open up the little floating explorer and drag Flame Controller from the explorer and drop it into the ice tree. Okay, let's take the out name parameter and let's plug it into the null name input right here in the null controller force, and voila, everything, all the red goes away. Perfect. So that means stuff's working, right? Of course. Okay, let's open up the null controller force here and see what changes we can make here. The F curve here allows us to go ahead and control the profile of the effect. I don't really need to at this point in time. I'm just going to leave it alone. If I need to, I'll come back to it, but I don't really think I'll need to affect that too much, if at all. The strength, let's increase it to something really high. Let's go up to like 20. And we don't want the particles to be pushed away from the null center. What we want is to use an input direction that we can select down here, which in this case is going to be Y and +1. That way the particles are pushed up like I explained earlier. So let me close that. Now the gravity force right now is set to -9 as the default. But we don't have to stick to that. Instead, what I'm going to do is put in a positive number so the gravity is reversed. The gravity actually pushes up, which is what I want. So I'll put 0.5 instead. So it's a very subtle gravitational effect that is going to be exerted on our particles. Okay, so next thing I want to do is I want to randomize this a little bit more. And let's actually go back and play our particle simulation and see what we have. And this is what we have so far. Particles are kind of spinning and they're stopping right here. They're not reaching the null force. So why is that happening? Well, we could move the null closer, but that's not what I want to do. If you notice when I play this, the particles come out a little bit slow. So let's go back to the ice tree. Let's open up our PPG for the actual emit from surface compound, and the speed is probably way too slow. So let's go ahead and more than double it to about a speed of 50. And now you can see the particles reach out much farther, which is much better. And you can see when they hit that null, they kind of have this little curvature where they just go up. They just get kind of bounced up. And the gravitational force of 0.5 is working on the particles, but it's not having a super drastic effect because I used a small amount, only 0.5. So there we go, kind of cool. Okay, let me stop the simulation there, and let's keep working on this. Okay, now if I go back and I play this, you're going to notice something strange. The particles are going almost in a straight line. They're kind of having this jittery effect, which is the way that fire would behave. But if you look at it closely, if you look at the overall profile, the silhouette of the particles, they're in a perfectly straight uniform line. And that, of course, doesn't look very realistic. We need more of a jittering effect. We need this thing to kind of snake, behave more like kind of like this wiggling snake, and just kind of snake its way up and down and left and right and kind of randomize itself a bit. So to do that, we're going to come over here to the preset manager, and we're going to go ahead and let's go ahead and type in turb for turbulize, and you'll see we'll have this turbulize around value node or compound. Let's bring that into our ice tree here. I'm just going to collapse it because it's so big and takes up so much room. So I'm going to take the value here and I'm going to plug it into a new force input here of the add forces node. And yes, you can do that. You're not limited to only using forces like gravity force and wind forces and null controller forces. You can actually plug in some of these compounds like turbulize around value compounds into the add forces parameter here. And now what you can do is you can come in here and randomize some of these values and create a nice snaking effect for the fire. So let's dig in here and see what kind of parameters that we have available to us and what we can change. We have a base value up here, and the base value is going to determine what the default value is for the parameter. So for example, here we have X, Y, and Z, and they're all set to 0. What these values mean is they're directions. They're 3D vectors. Basically, if I were to put in, say, for a base value of 1 in Y, the particles are going to go up in the Y. If I place 1 in the Z, the particles will go 1 unit in the Z, which is pretty easy to understand. But how can we use this node to kind of randomize the effect and cause the particles to go left and right and up and down sort of at random? Well, that's what we had this variance parameter down here for. What I'm going to do is put 3 for the variance in the X, and let me put 3 for the variance in the Y. For the Z, I'm going to put 0. And there's a reason why I put in 0. If I go back here to my view, if I see down here in the lower left my actual my world coordinates here in 3D space, you notice that Z is the same direction that the particles are going into. So if I put anything in Z, what's going to happen is the particles will sometimes go forwards and sometimes try to go backwards. And a flamethrower wouldn't do that. Flamethrower would shoot flames only forwards, but they wouldn't suddenly go back and then forwards and back and then forwards. That really wouldn't make any sense. So we'll leave Z at 0, but for Y and X we'll put at 3. And what this means is that if the base value is 0 and 0, right? Say for example the Y base value is 0, and the variance is set to 3. What this means is that the base value is going to be 0. So these particles are not going to go up and they're not going to go down. It's just 0. They're neutral. They're just going to go straight. But because they have a variance of 3 in the Y direction, sometimes the particles may jitter up or down. And it'll be a value between 0 and 3. So sometimes some particles may go up 1. Sometimes they may go down -2. Sometimes they may go up to a maximum of +3. So adding that variance is great for achieving that kind of a randomized look to the particles. Okay. Now for the turbulent scale, we'll leave that alone. We want to go ahead and check on animated, and let's increase the animation speed to something a little bit more drastic, something like 2.5 will work out pretty good. I'll leave the complexity alone. Noise type, you can choose between Perlin and Simplex. I'll leave it on Simplex. And these parameters down here for the turbulent center and the movement, I'm going to leave them alone. So this will work out pretty good. Now let's go back to the first frame of the animation, play it again. And now you notice we get this nice snaking effect. If you look carefully, you notice some particles just go up and down, left and right, up and down. If we look at this from the top view, we can see particles are going left and right. So they're snaking. They're snaking all over the place. But they're not snaking too far where some particles are going way up here or way down here. The variance is controlling the particles so they don't go too far past 3 or -3. So the particles will go at this lowest point or this highest point. They'll only go as far left as here and as far right as about here, which is really cool and adds a really nice touch to the particle simulation. So let's stop the simulation there. Now it's starting to look more like flames. Okay, so you can see we have our particle simulation working out pretty good for us. We got a nice little flamethrower effect. The flames are snaking just the way we want them. They start off small the way it's supposed to, and then suddenly just whoosh, they just get pretty big. And we have this null controller, which is right now inside the flames. It's being burned alive, and it's kind of at the end pushing the flames a little bit up. Nice little subtle effect, so it's not too strong. We don't want it to be too strong. Subtlety is key here. And we have these particles kind of spinning around. So there we have this nice jittering and snaking effect in all directions, up, down, and left and right. Perfect. Okay, so this is looking pretty good. I don't think there's any more changes I want to make to the ice tree here. So I'm pretty happy with the simulation effect. And we have ourselves quite a number of nodes here. Although really this is a pretty simple ice tree. It's not too complex. I think it's perfect for a beginner. Really shows how you can plug in all these particles together to combine them into different forces, and how you can spin particles, change their size, and modify the particle size over time, whether it's the timeline or whether it's the actual lifespan of the particles themselves. Okay, so we saw how that works. What I'm going to do is end this video here, and in the next one we're going to start working on the particle shading effect, because if we go ahead and render this out, we can see that the render region reveals these nasty spheres. So let's cancel that out. I'm going to end this video here, and in the next video we're going to focus on creating the actual fire look of the particles using some of the new exercise 7 volume shaders that we have available to us with ice particles. So I'll see you there.